All right, guys, so here we go. We got another async. We're doing inverse trig integration today. So there's three rules we have to know. There's this guy, which ends up being arcsine of x over a plus c, right? So that a comes along for the ride on the inside of the arcsine. And then over here, this is a little weird. This is 1 over a arctan of x over a plus c. So there's two right there, two rules you got to know. And one more is this guy. This is 1 over a arcsecant of the absolute value of x over a plus c. All right, so these are the three rules you need to have memorized. Luckily in integration, we don't do arc cosine, arc cotan, and arc cosecant. We just do the sine, tangent, secant. So we don't do the co-functions. If you want to do the co-functions, you'd actually just put a minus in front of them. So that's really not that bad. So let's see how we put this into action. We got three examples for you to do. So example one here. So the way I like to think about these is I want to try to find my a, and I want to try to find the thing that's being squared. So I like to think of this as, all right, well, how can I simplify? First, I could pull the 3 out. So this is 3 times 1 over the square root 9 minus 4x squared dx. And then from here, we could see this is 1 over the square root. That looks like an arcsine. Looks like an arcsine based on our rules from above. So for arcsine, I need an a squared and an x squared. So that means, well, a squared has to equal 9. So a equals 3. So I could write this as equals 3 times the integral of 1 over 3 squared minus 4x squared. And here's where these problems get a little tricky. We need to make one extra little manipulation. So this is 3 times the integral of 1 over 3 squared minus, and 4x squared, I can write that as 2x squared. Right, and there's the trick that actually lets us do the problem. We want it to be something squared, which allows us to do now a u substitution. So we can do u equals 2x, du equals, I guess we can, dx is equal to du over 2. So this is now equal to 3. I lost my square root somewhere. 3 times the integral of 1 over 3 squared with a square root minus u squared du over 2, which is 3 over 2 integral 1 over the square root of 3 squared minus u squared du. All right, and now this guy looks like our arcsine. This guy looks like our arcsine. So this is 3 over 2, right? It's a squared minus u squared. So this is going to be arcsine. And if you look back up here, it's arcsine x over a. So arcsine u over 3 plus c, and u was 2x. So this is 3 over 2 arc sine 2x over 3 plus c. There's our final answer. All right, so it might look a little complicated. Watch it once, twice, 3 times. You'll be okay. All right. Now here we go, example 2. Example 2. So there's no square root in the bottom, so this better be an arctan. And indeed it will be. Let's do a little simplification first. So this is equal to negative the integral of 1 over 16 plus 2x squared dx. And we look back up here. For arctan, we need something squared plus something squared. So this is going to be equal to the integral of 1 over, I guess this will be 4 squared, plus, now this is where it gets a little weird, the square root of 2 times x squared. Right? Because the square root of 2 is the square root of 2 dx. Right, so now I have a is 4, and I need to do another u substitution. U equals the square root of 2x, so dx equals du over the square root of 2. So what do we get here? Negative integral 1 over 4 squared plus u squared. Doc, stop using 4's and u's in the same problem. Du over the square root of 2. This is equal to negative 1 over the square root of 2. Integral of 1 over 4 squared plus u squared, which is equal to, using our arcsine rule, negative 1 over the square root of 2. We get 1 over a times arctan x over a. So we have 1 over a, arctan u over a plus c. And then we should plug u back in. U is the square root of 2 times x, so this is negative 1 over the square root of 2 times 1 over 4 arctan square root of 2 times x over 4 plus c. All right, so if you know the rules, if you know the integration rules, it's just using our u substitution from earlier. All right, and now finally we have question 3 here. Now question 3 is a little tricky. It doesn't exactly look like any of our rules to begin with. But you might notice we can do a little factoring. Right, so let's start. Let's pull the 6 out. 1 over. And we notice we can actually factor out an x squared out of these two things, right? So I can factor out x squared, 3x squared minus 6 dx. Right? Factor out that x squared, which then gives us 6 times the integral 1 over the square root of x squared is just x, square root 3x squared minus 6 dx. Which again, we can make the simplification, well, not simplification, but 6 integral 1 over x square root of 3x squared minus 6. Actually, I should write 6 as minus the square root of 6 squared dx. Make our u substitution. U equals the square root of 3x, so dx equals du over the square root of 3. So this thing gives us, I guess, 6 over the square root of 3. That comes from this guy. Integral Ooh, we can't do this one. Ooh, Doc made a mistake. That's all right. Doc makes mistakes sometimes, so we can't do this one. Can't do this one. That's all right. Ignore me for a little bit, and then because of that, on our problems down here, we can't do this one, so we'll ignore number 6. But the other 5 you can do. Do those 5 problems, and you should be good to go.